Hello, everyone. Welcome to another fresh episode of Coding Roy, where we discuss brand new questions of various famous websites. Today, in the same pursuit, we have brought forward this interesting question. You can also find it by the name of single repeated element or something like that. It's an advanced version of a question that we had done yesterday. Um the question is was that of single element. If I remember, the heading was that of single element. We have actually five different solutions of this programming question. It's a very good question. Uh, and there are various steps to this question, right? So you can understand this question through various means. You can solve it in various ways. Um, we'll be discussing all of them. As you can see, I have the solution number 1, solution number 2, number 3, number 4, and number 5, all present with my right now, but we will be discussing them one by one, and I think I need uh, two or more than two videos to explain all the solutions. Here we'll be just discussing the main concept behind the problem and one of the most basic solutions, so we could say the brute force solution to this problem available. So let's begin. Given an array of integers, right, every element appears thrice except for one, which occurs once. Find that element which does not appear thrice. I think it's the question is unambiguous. It's the most clear question that we could see. So that means here's an example. If, like, in this array, let's say 1 is repeating thrice, right, 2 is repeating thrice as well, 3 is repeating thrice, but 4 is just present once, so the output should be 4, and there's exactly one element that is present once. um, there are some additions to it. Your algorithm should have a linear time complexity, so we have to mention that. So it should be order of n, right, at max, in time complexity, right? Can you implement it without using extra memory? This is a very interesting addition to the problem. We'll be discussing that in solution number 4 and 5, right? And this thing you can discuss in 1, 2, and 3. 3 also, it's like a midway between 4 and 5. By the way, I think we will just cover solution 1 and 2, which is basically the same solution with just minor changes to avoid memory uh, like limit extended. So let's just quickly move on to the first solution which I have in mind. So it's a very simple brute force solution. What I do is that I keep an array, or here a map, which has a key value as the element of vector A. Okay, here vector A is the input vector that contains the elements. Okay, the thrice repeating and the single repeating element. So what we do is that we have element as the key of the map. Let's say I have implemented this map n m. So let me give this the name m element. So element is an element of array. Okay, so that and the value. So here I have kept it here. You can see uh, it is the m of ai, right? So ai is nothing but a value of the element, and that is the key, which is the one of the values present in this vector. Now the value will be the frequency, right? Frequency means number of repetitions we have seen right now. Okay, repetitions observed till now. So we'll see how what does it mean. So we just so here again I have another set here. Okay, now this set will contain all the possible values for answer, right? For answer or result, right? um, and then we'll just add and remove the values from the set based on whether we are when we add the element when we think that there is a possibility that this element can be the result, We remove it when we find that there is no possibility for it being the result, right? At the end, we just have a single element in this set, right? So we add it here, let's say, and we erase the element here, okay? And those conditions are also very simple. So what we do is that, so m dot find ai is one of the functions of the map which returns m dot end if the element ai is not present in the map currently. So this condition is that it is not equal to m dot end. That means the ai is present inside the map. Ai key is present inside the map, okay, is present. So that is one case, and this is the other case, that ai is not present currently in the map, right? Ai is not currently present. It means that we are seeing ai for the first time as we traverse this vector, right? So when we see it for the first time, we enter it into the map and give its frequency or number of repetitions as 1, because we have just seen once. We have just observed one repetition, and then we insert AI into the set, assuming that this AI could be a potential candidate because it's a part of the array, and we have just seen it once till now. Now, the other case, when we see that AI is already there in the array, that means either we are seeing it for the second time or we are seeing it for the third time. So we update that thing that m of AI plus plus, we if it is second time, then m of AI becomes 2. If it is for the third time, m of AI becomes 3, based on the frequency, that is the number of repetitions observed till now. And an interesting fact is that when m of ai equals to 3, when it is repeated for the third time, we remove it from the set S, saying that this element cannot be our answer because we have already seen that it has been repeated 3 times inside the array. So we just remove it from S, and so all the elements which are repeating thrice are removed from the S eventually. They're added actually in the first place when we see first repetition, but when we see the third repetition, they're removed from the set, and then we return S dot begin. So that's the only element, so that will be present at the S dot begin, so that we return. So that's our solution. It works fine. It takes order of n time because, again, set, we can assume it like n insertions and deletions are taking about that much time. So it works, but the problem is it gave me memory limit exceeded in interview bit. Also maybe in lead code it can give similar results. So what I did is that I just made a few alterations. The alterations here, so what I did is that I just commented this set thing here, so we don't need these sets anymore. So with just a single map we can do it. So what I did is that I just put the value inside the map during the first encounter and made its frequency as 1, like in the previous case. I also did the increasing the frequency as we see the newer repetitions of the same number. But here, when we saw the third repetition of a given number, I just erased it from the map. We don't need that information anymore, so I just erased it from the map. And finally, all the numbers which are repeating the 3 times are removed from the map, and only we have the solution that the only thing which is present in the map with the only key value pair is that of the singly repeating element, and that will be present as the first value in the pair, and the other one will be the frequency, which is 1, because that will only be visited once. So when I do m dot begin, that gives me the iterator, the first element in the map, and this is the operator that gives me the link to the first, that points to the first element. So that gives me the result as output. So instead of using set, I have removed the usage of set here. By the way, you could have guessed it from that. If you could guess it, then it was great. Okay, so now it worked without any memory limit exceeding. So again, then there are some future arguments, the future discussions which are required for this question. We'll be discussing that in a future video, right? So till now we have used maps for solving the question. Now just a small hint for our future videos, you just have to see contributions, okay, of repeating elements to the sum of uh, bits at given position position from 0 to 31, all the bits, their sum, to their sum, what is the contribution of those elements which are repeating. So for example, a given number, so let's say we have let's say 10 elements in the array. Now all these 10 elements have 32-bit representations, right? 1 0 1 0 0 0 0, like this. So from 31 till 0, so there are all the bits. So like that we can write the bits for all the 10 numbers, right? 1 till 10, and then we sum the individual bits, right? The values at the individual bits. So we just sum, that is basically the sum of the ones present in this, because zeros don't add. So we just finally find the sum. So if it is 1, then 0, then 1, then 0. So if there are 10 such repetitions, now I'm just adding for 2. So if there are two ones, so I'll just write 2. If there's single one, I'll add 1. So like this, we'll just do the sum, and you have to find the characteristic of the sum. That will give you an approach to solve this question. Also, you can have a look at this code and try to understand. It's very straightforward. Once you understand what this is, we'll discussing in the next video. Also, the link is to the GitHub links are mentioned in the description, and the link to the questions are also mentioned in the description for your reference. Thank you. This is Dinesh Mohanty signing off.